Hello friends, welcome to Automation Community. Today in this video we are going to discuss an example which will be about industrial oven control. So let's look at the example first. Industrial oven control. The oven should preheat for 10 seconds. Then a buzzer will turn on. The food tray should be placed inside and then only the buzzer will turn off and it will maintain the set temperature for 10 seconds and then cool down for 30 seconds. So we will use a normally open contact for start button. So when start button is turned on, then the process of preheating will start and it will be for 10 seconds. For this, we will use a timer known as pulse timer or TP. And then after 10 seconds, the buzzer will turn on. The buzzer will be turned off when the food tray is placed inside the oven. So the presence of food tray will be detected by a sensor. So the sensor will detect the presence of food tray that will turn off the buzzer. And after turning off the buzzer, it will maintain the set temperature for 20 seconds. For maintaining the set temperature for 20 seconds, I will use again pulse timer TP. And after 20 seconds, the process of cooling down will occur and it will be for 30 seconds. So for cooling down, I will also use pulse timer and the preset value will be 30 seconds so that the process of cooling down the food will be 30 seconds. So moreover, we will be also be using some memory bits. So let's move to EcoStruxure Machine Expert where we will draw a ladder diagram for industrial oven control. I will open EcoStruxure Machine Expert Basic. I will keep read protection as inactive and write protection as inactive as well. That results uploading the application from the controller is unrestricted and downloading an application to the controller or modifying the application in the controller is unrestricted. So if I keep it active, then uploading the application from the controller is disabled due to the blank password. That means if we keep it active, we have to set password here. And then uploading the application from the controller will be restricted. That means it will need a password, and also downloading an application to the controller or modifying the application in the controller will be restricted. That is, it will ask for the password that we have put it here. So for now, I will keep it inactive for read protection as well as write protection. And then I will click on apply. So after that, I will go to configuration tab. So here we have to select the logic controller. We have to configure the device in this tab. So here is a list of different logic controllers. I will be using TM221 C24R. I will click on it and then drag it to here. Do you want to replace TM221M16RG by TM221C24R? You may lose some features and associated configuration. So I want to replace it, so I will click on Yes. So here is a device description about TM221C24R. That is, it has 14 digital inputs, 10 relay outputs, 2 analog inputs, 1 serial line port, and 100 to 240 volt AC power supply controller with removable terminal blocks. So after that, I can also go to serial line, where I will select protocol as TMH2GDB. I can also set it as Modbus ASCII TMS2GDB or Modbus Serial IO Scanner. I will keep it TMS2GDB for now. And then I will click on Apply. So if I keep protocol as TMS2GDB, then there is no need to set the serial line settings. So after that, I will click on Programming tab. So here I will be drawing ladder diagram. I can also click on this option to set a full screen mode. I can also click on this option to unset full screen mode. So for now, I will set the full screen mode. And then I can also zoom into it like this. I can also zoom out like this. Firstly, I will insert a normally open contact. I will assign address to this normally open contact as I0.0. I will also add symbol to it as Start button. Yes. And then I will insert a coil here and I will assign address to this coil as Q0.0. I will also add symbol to it as preheat. Yes. So when start button is turned on, the process of preheating will start. And this process will be for 10 seconds. So for this, I will use a functional block, a timer, and it should be TP, pulse timer. I will change time base to 1 second and preset value as 10. And then I will click on apply. So when start button is turned on, the process of preheating will start and it will be for 10 seconds. And after 10 seconds, the process of preheating will stop. And then I will add a new rung and I will insert a normally open contact. I will assign address to it as I0.0, which is a start button. So after preheating, the oven should maintain the set temperature. So for this, I will insert a coil and I will assign address to it as Q0.1. I will also add symbol to it as set temperature. Yes. So the process of maintaining the set temperature will be after preheating. So this process will start after 10 seconds. That is after stopping this process. So this coil should be off. So here we will use a normally closed contact. I will assign address to this normally closed contact as Q0.0. So when start button is turned on, the process of preheat will start and it will be for 10 seconds. And after that, this process will stop. So this coil will be false after 10 seconds. So when this coil will be false after 10 seconds, the current will flow through it as the start button is already turned on. The preheat, this coil will also be false after 10 seconds, thus the current will flow through it and the process of maintaining the set temperature will become true. So, but it should be true for some period of time, that is 20 seconds. For that, we will use a functional block, timer, and it should be TP. I will change time base to 1 second and preset value as 20 and then click on apply. So firstly, the process of preheating will be done for 10 seconds and after 10 seconds this process will stop and maintaining the set temperature will start and it will maintain the temperature for 20 seconds. And after maintaining this temperature, but before maintaining this temperature, the buzzer should turn on. So for that, I will add a new rung and I will insert a normally open contact. Or simply, I will delete this change this to buzzer. Yes. So after preheating, the buzzer will turn on. And I will assign address to this normally open contact as I0.0, which is a start button. And then I will insert two normally closed contacts and then a coil. Firstly, I will assign address to this coil as Q0.1, which is the maintaining the set temperature. So for this process to occur, the process of preheating should have been done. So I will assign address to this normally closed contact as Q0.0 and also the buzzer should be off. So I will assign address to this normally closed contact as Q0.2. So this buzzer will be stopped when the food tray is placed inside the oven. That will be detected by a sensor. So there will be one more normally closed contact here and that will turn off the buzzer. So I will assign address to this normally closed contact as I0.1 and I will also add symbol to it as sensor. So it will detect the presence of food tray and when it senses the presence of the food tray, then the buzzer will stop. And when the process of preheating is done and buzzer is stopped, then the process of maintaining the set temperature will start and it will occur for 20 seconds. So for that, I will use a timer here that will be TP. I will change time base to 1 second and preset value as 20. So the process of maintaining the set temperature will be for 20 seconds. And then I will add a new rung and I will insert a normally open contact. And then I will insert a coil. I will assign address to this normally open contact as I0.1, which is a start button. And I will assign address to this coil as Q0.3. I will also add symbol to it as cooling. So the cooling process will be done after the process of preheating, then buzzer on and then off, and then maintaining the set temperature for 20 seconds. After these processes, cooling should be done. So firstly, this process, preheating process should have been done. So for this, I will insert a normally closed contact and I will assign address to it as Q0.0. And also the buzzer should be off. For that, I will insert a normally closed contact here and I will assign address to it as Q0.2, which is a buzzer. And also this process should have been occurred and it should have been completed. So for this, I will insert one more normally closed contact and I will assign address to it as Q0.1. So after preheating, after turning on and then off the buzzer and then maintaining the set temperature for 20 seconds, the process of cooling will occur and it should be there for 30 seconds. So for that, I will insert a timer here and I will change this to TP, pulse timer. I will change time base to 1 second and preset value as 30 and then click on apply. So when start button is turned on, the process of preheating will start and it will be stopped after 10 seconds. And when this process will stop, then the current will flow through it and buzzer will start. And when buzzer will start, then a food tray is placed inside the oven and this sensor will detect the presence of that food tray. That will result the buzzer will stop. So when preheating is done and buzzer is stopped, the process of maintaining the set temperature will start and it will be occurred in 20 seconds. And after that, it will become false. So after that, when the process of preheating has occurred, the buzzer has turned off and the process of maintaining the set temperature has occurred, then the process of cooling will start and it will be for 30 seconds. So in this way, it will end the process. So I will exit full screen mode and I will compile the program and I will go to commissioning and launch simulator. And then I will start controller. To do so, click OK. So I will go to programming and click on full screen. So when start button is pressed, the process of preheating is started and it will remain true for 10 seconds only. And after that, the buzzer will turn on. So this buzzer will turn off only if a food tray is placed inside the oven. That is, when a sensor detects the presence of food tray. So when it detects, then the buzzer will stop and the process of maintaining the set temperature will start. and it will occur for 20 seconds. So after 20 seconds, the process of cooling is started. That is, preheating is done, buzzer is turned off, and the process of maintaining the set temperature has been occurred. Then only cooling has started. So this process will be there for 30 seconds. And after that, this process will stop. So after 30 seconds, the process has ended. It was all about this example. Thank you for watching.